Unit 10 is a very short unit. It's on finding volumes, and we're going to start with just a bit of a review of some of the area formulas that you probably know, and then also a few of the volume formulas that you're probably familiar with from other math classes. So the I can statement for 10.1 is I can compute the volume of a cylinder. So let's write the word cylinder here, and it's going to be really helpful if we draw a picture of these. So the first one says area of a rectangle. So let's go ahead and draw a rectangle. So remember, a rectangle has two sets of parallel sides and 90-degree angles at each one of the vertices, so it looks something like that. And the area formula could be thought of a couple different ways. We could do length times width, or we could also say the area is the base times the height. This is probably a little bit more common, so we'd have the base here and then the height right there. So there's the formula right there. Let's keep that one in mind. Remember the units that we'd have if we had, say this was feet here for the base and then feet here for the height. The units would be feet squared when we're done. So keep in mind area is always measured in square units. That's helpful for remembering a couple of these formulas. Area of a triangle. The area of a triangle would be 1/2 the base times the height, or we could do the base times the height and then we could divide that by 2. I do want to show you a couple of pictures. A lot of times when we draw a triangle and we're talking about finding the area, this would be the height, or sorry, the base, and then this would be the height. Remember, the height is always that distance from the top straight down to the bottom. It has to meet the line containing the base perpendicularly, meets it at a right angle. So sometimes we'd see the height inside. Other times we get lucky and we happen to be dealing with a right triangle. So this is the base and this is the height. And then other times we're dealing with a triangle where this is the base and then we kind of have to extend some auxiliary lines right here. So this would be the base and this is the height. Works that way each time. It's always going to be the base times the height, but we want to keep in mind that height always has to be that vertical distance. So from the tip up here down to the line containing the base might be outside, might be inside, or we might get lucky and it might actually be part of the triangle itself if it's a right triangle. And then remember the formula for the area of a circle. Down below here we've got the circumference of a circle, but those formulas are very similar. The area of a circle is pi r squared. So remember, the only thing that we need to know about how big a circle is we just need to know the radius. So this right here is the radius. The radius is the distance from the center out to the edge. If it were all the way across, that would be the diameter. So the radius is exactly 1/2 of the diameter. Okay, and again I'll write on here that r stands for radius, so r means radius. So the radius is the distance from the center to the edge of the circle. The diameter is the distance all the way across. So if they gave us the distance all the way across, or they gave us the diameter, we just cut it in half and that would be the radius. Down here for the circumference of a circle, just as a quick reminder, circumference is just the distance around the circle. It's like the perimeter of a circle. Circumference is just a fancy word for perimeter of a circle. So the circumference is 2 pi r, and you might remember that these two are very close to each other. This one is pi r squared and the circumference is 2 pi r, and the way you can keep these straight is area is always measured in square units, so that's why the r has the square on it. So the 2 is a coefficient out in front here on the circumference, the 2 is an exponent up here. Okay, let's talk about volumes for just a second. Volume of a right rectangular prism, that's a fancy word for a box. So let's draw what a box would look like. I'm going to draw a rectangle like this, and then we're going to draw some sides going back at an angle like that. And then if I connect those, and again the key is to kind of keep these perpendicular, that kind of looks like a three-dimensional box even though we've drawn it on a two-dimensional piece of paper. So if I draw a line straight down here, straight there, parallel to the front and parallel to the side over here, and then parallel to these sides, we get what looks like a three-dimensional box because we've drawn the sides that are hidden, or those edges that are hidden, back behind there. So we've got a length and we've got a width and we've got a height. So the volume of this would be the length times the width times the height. Now I do want to remind you of something, and that is, let me go ahead and circle these. Let's see, let's just get that one circled. So that is, when we develop this formula, we normally think of it this way. We normally figure out the volume of some type of solid like this by doing this. We figure out the area of the base and then we multiply it by the height. So in other words, we figure out how many squares we could fit along the bottom, and then we figure out how tall we could stack them. So the length times the width, that's just the area of the base, and we use a capital B to represent that, and then we multiply it by the height. So either way, that would be fine. Volume of a cube, let's draw a cube here. So a cube's got to have a square face, and then all the other ones are matching squares. So if I were to make it look like this, that doesn't look too bad. It's not perfect, but if this is a side of a cube, let's use S for side, S for side, and S for side. This would be the length, the width, and the height. So the volume of a cube, we just take whatever the side is and then we'd cube it, because the volume would be S times S times S. Easiest way to write that would be S cubed. Okay, so we've got all of our formulas. Just a quick review. A parallelogram, area of a parallelogram would be something like this, except for we can kind of push it over a little bit. So this would be the base, and then again we've got to have that idea of the height right here. So the area, a rectangle is just a special type of parallelogram, so the area formulas would be the same. Okay, let's slide down here and let's talk about a cylinder. So a cylinder is a shape like this. A cylinder has a circular base, so let's write the word circular, circular base, and sides that rise vertically from the base, they are parallel to each other, parallel to each other. And finding the volume can be thought of in two parts. So it's similar to what we did up here. What we do is we figure out the area of the base. So we figure out the area of the base, and I'm going to use a big B for base. Okay, in other words, we're going to figure out how many cubes can we stack on the bottom. So we're going to figure out how can we divide this up and figure out what the area is of that base. How many cubes could we stack on the bottom there? What's the square area right there? So how many cubes could we stack on the bottom? And then we're going to find the height. We're going to find the height. So in other words, that means how high could you stack those cubes? So we're going to find the area of the base, and then we're going to figure out how tall we can stack those. So you'll notice that this is very similar to what we did up here when we were finding the volume of a rectangular prism or the volume of a box. We figure out how many squares or how many cubes we can fit on the bottom, and then we figure out how high we can stack them. So when we get done, we're going to multiply those. So we're going to multiply to get our answers. So we're going to take a look at this example right here. So we want to figure out what is the area of the base. So find the area of the base and then multiply the area of the base by the height. So we're going to figure out what the area of this is right here. So what is the square units, or how many cubes could we fit on the bottom here? So this is a circle. So the area of the circle, I'm going to write a big B for the base, is pi r squared. So that's going to be pi times 6 squared. So let's figure out what that is. I'm going to grab a calculator here. So I've got the calculator up. We're going to go ahead and do pi. So pi is, let's see, on this calculator, pi is right here. It's above the caret key, and you'll notice that it's in blue. So let's go ahead and hit second pi. And then we're going to do 6 squared. I am going to go ahead and put that in parentheses. That's just a good habit to be in, although you could get away without the parentheses. So we've got pi times 6 squared, and we get this, 113.0973. So I'm going to carry that out quite a ways. So 113.09733, 113.09733. Okay, that's the area of the base. We're going to use that in just a second, because now we know we can fit 113.09 squares or cubes on the bottom, and then we want to figure out how tall we can stack those. Well, we're going to take this and we're going to multiply it by how tall we can stack them. We can stack them 11 units tall. So we're going to take the 113.079, 97. Let's double check that. 9733. Okay, and then we're going to multiply it by 11. So we're going to grab the calculator. Now the cool thing about leaving this in the calculator is I don't need to store all those. I can just hit times 11, and we're going to get this answer right here. 1244.07, we'll round to the nearest hundredth, that's a 0, so 1244.07. So 1244, let this catch up here, 1244.07. Now I'm going to leave a little bit of space here. This is the answer, but remember, this was in meters, so technically there was meters here. So this would be in meters squared, and then this was meters, so I'm going to put an M on the end of that. meters squared, and then we multiplied by 11 meters. So when we multiply the meters squared by the meters, we've got meter times meter times meter. This is going to be cubic meters. So remember, volume is measured in cubic units, area is measured in square units. So here's our answer right there. So if you think about what we did, we found the area of a circle on the bottom, so that was the big capital B for the area of the base, pi r squared, and then we multiplied it by how tall it was. So the formula for the volume of a cylinder is this. It's pi r squared, that's the area of the base, and then we're going to multiply that by the height. Okay, so you really need to memorize this formula. So please make sure you memorize that formula just like you memorize your times tables, just like you had these formulas memorized up here in the warm-up. Those should just be easy recall. Recite those at the drop of the hat. So please make sure you have that memorized. So I'm going to put a star by this. And then I'm going to do one more thing. Most of the problems that we do today and the formulas that we learn in this unit, you can just figure out what are the parts that I have, plug those into the formula, and it will spit out the answer. So I'm going to change colors here, and I'm going to do this. The volume of a cylinder is pi, and then the radius squared times the height. The radius on this one, again, this gives us the radius because it's from the center to the edge. That's going to be 6. And the height is 11. So I'm going to grab the calculator, and you can do the same thing here. So I'm going to grab the calculator, clear this off, and we're going to do second pi. Pi is right here above the caret key. I'm going to do parentheses 6, close the parentheses. I'm going to square that, and then I'm going to times it by 11. Now you could put this in parentheses, you can use the times. In fact, you could actually just put the 11. It knows what implied multiplication is. But take a look here. That quickly, by just typing this in, we get exactly the same answer, the 1244.07. So 1244.07. Now the thing the calculator doesn't do is it doesn't tell you what the units are. So remember, we're measuring a volume, so this has got to be in cubic units. So whatever the measurement was, make sure they're both the same. So we've got meters here, so we end up with meters cubed. So I'm going to come down here. We're going to take a look at a couple more problems. We're going to talk about a typical question that many people have when we're doing these, and then we're going to do a problem from the assignment. So it says find the volume of each cylinder below, round answers to the nearest hundredth. Be sure to pay attention to the dotted line. Does it represent a radius, or does it represent the diameter? If it represents the diameter, remember the formula does not involve the diameter, so we've got to make sure that we compute the radius before we plug those in there. And again, also, don't forget the units. Always make sure you've got the units right. So just as a reminder, I'm going to write down that the volume of a cylinder is, you've got it up above, but it's off the screen here, it's pi r squared. It's the area of that circular base times the height. Now you'll notice on this one that it's tilted sideways. That doesn't change how we're going to do the problem at all. This is still considered the base, even though this radius right here, and it is a radius because it goes from the center to the edge, even though that's up and down. So this is going to be the base, and this right here is the height. So we're going to plug those into the formula. So we get V equals, this would be pi. We're going to do 7.8, and we're going to square that, and then we're going to multiply it by the height of 11.3, and this is in feet, so we've got to make sure that we use feet cubed when we're done with this. In fact, one technique you can use is just write down the units before you throw this into the calculator. Now I'm going to show you a couple different ways that you can put this in the calculator. So, oops, let me leave this right here. So we're going to put it in like this. Clear this off, and we're going to do second and pi. And we're going to type this in 7.8. I'm going to square that, and I'm going to close the parentheses right there, and then I can just type the 11.3. Okay, so I've got the 7.8. That was the radius of the base. We're going to square that, and then we're going to multiply it by 11.3. So I'm going to hit enter. We get, let's see, 2159.819. That 9's enough to bump that up, so that's going to be an 8.2. So 2159.82. 2159.82. We've already got the units on there. I always like to bring up the calculator and just make sure that I've typed that or written that correctly. Looks good, so we're all set to go. Okay, so it's literally that quick. That's the answer. So notice on this one right here, we're going to have the volume equals, I'm going to write this down, pi r squared h. Pi r squared is the area of that circular base. We're going to multiply it by the height. So the volume here is pi, and then we're going to have 2.2, and we're going to square that, and then we're going to multiply it by the height of 10.3. This is in inches, and that is in inches, so I'm going to write inches cubed right here, and then we're going to grab the calculator. Now, if you want to type this in from scratch, that's awesome. If you want to, we can make this maybe a little bit quicker by hitting this, second and enter. That's the deep recall feature of the calculator. So we'll recall previous commands and then we can just edit them. So notice that this one is just 10.3, so let's turn that into a 0. And notice that what we've got underneath inside the parentheses is 2.2. So I'm going to go ahead and write down 2.2. And you'll notice that I don't have any extra spaces or anything like that. There's nothing to edit here. You can hit enter when you're in the middle of this whole thing and it will compute the answer. But let me just make sure that I've got this right. Pi 2.2 squared times 10.3. We're going to hit enter. Spits out the answer 156.614, so that's not enough to bump this up, so 156.61. So 156.61, we're going to circle that and we're all set to go. Okay, let's take a look at this last one. You'll notice there's a asterisk by this, so we do need to be a little bit careful. Again, I'm going to write down the formula so I make sure I get it memorized. Pi r squared h, so area of the base times the height. So we need the radius, and take a look right here. That is not a radius. That dotted line goes all the way from one edge to the other. So this is actually the diameter of the circle. So that means that the radius would be 5 centimeters. So let's grab the formula and let's plug this in. This is going to be pi. This is going to be 5 squared, and then we're going to multiply it by 11. So on this particular calculator, I find it quicker to just go ahead and type it in from scratch. So we're going to do pi, I'm going to do 5 squared, and then I'm going to do 11. Now, I really wouldn't recommend this. It will give you the answer, but it just looks kind of weird. So I'm going to do this. I'm going to hit second and pi, and then I'm going to do parentheses. We'll do the 5 squared, close the parentheses, and then we'll do the 11. Now that looks a little bit better. You can tell what the quantities are that we're multiplying. It doesn't look confusing at all. I'm going to go ahead and hit enter, and you'll notice that we get the same answer. So 863.937. That 7 is enough to bump this up. So we're going to go 863.94. So 863.94. Now if I circled the answer right here on a test, I'm not going to get all the points. So I want to make sure that I've got the units on here. This is why putting the units on there before you type it into the calculator is a good idea. Now, some people usually say, well, wait a minute, how can we get cubic units, or how can we have square units when we're finding area if we've got a round figure? Well, what we're doing on something like this is we're doing this. We're going to chop this up and we're going to figure out, so we'll do the circle right here. So these each are little squares that fit entirely inside, but if I've got a little part of a square and a part of a square and a part of a square right here, what we basically do is we count up fractional parts or decimal parts of squares, and then we add them together. So when we figured out this one right here was 113.09, that doesn't mean that they're all perfect squares. What probably happened is, as we go through here, we've got a bunch of perfect squares in the middle, but around the outside edge, we've got parts of squares. So what we do is we add those up and see how many we have all together. So kind of keep that in mind. That's a typical question. If that doesn't make sense, please come and ask. And then let's turn to the worksheet and let's take a quick look at some of these problems. So the worksheet starts off and it's got problems that are very similar to the ones that we did. You'll notice that some of them give diameters and then others give a radius. If we flip over to the back side, same thing here, and then once we get to the last couple problems, it changes instructions. First of all, we don't have a diagram, and it says solve for the missing height or radius. Round answers to the nearest hundredth if necessary. So what we need to do here is, remember, the formula is V equals pi r squared h. They're going to give us the volume and the height or a radius, and then we need to find the missing piece. So if I were doing this problem, I look right here and it says the volume is 950 cubic inches. The 950 would go right here, and it says the height is 10 inches, so we'd put 10 right here, and then we'd go through and we'd solve. On the next one, number 12, which I'm actually going to do, it says find the radius of a cylinder with a volume of 108 pi cubic feet. So the 108 is going to go right here, and the height is going to go right here. So let's write this down. This is going to be 108 pi. That's the volume. and then we've got a pi over here. We've got the radius. Now it doesn't tell us what the radius is, so let's just write radius squared, and it does say the height is 12, so we're going to multiply by 12. So the only thing missing in this problem is the radius. So we've got the volume, 108 pi. We don't have the radius, so that's why we're keeping the r there, and we do have the height. And remember, pi, although it looks weird, that's just a number. So now we're going to go ahead and solve this using our equation solving techniques. We want to get the r by itself, which means we want to isolate that. So the first thing we're going to do is we're going to divide both sides. Notice we're multiplying by pi and we're multiplying by 12. I'm going to divide this side by pi and 12. We're going to divide this side by pi and 12. If we wanted to write 12 pi, that'd be totally okay. So multiplying by pi and dividing by pi, those are going to cancel each other out. We can cross cancel those to be a 1. Same thing here. So we're going to end up with an r squared on this side. And this is kind of cool because these are going to cancel, and I've got 108 divided by 12. Let's just check and see what that is. I think that works out very nicely. 108 divided by 12. We're going to hit enter, and we end up with 9. So 9 right here. Now, I'm hoping you remember how to do this. This is a quadratic equation technically. It's saying r squared equals 9. So to undo the squaring, make sure you say this right, we're going to take the square root of both sides. So when we take the square root, that undoes the squaring, so we get an r. And then over here, we get the square root of 9. Now, when we put the square root in there, normally we have to put a plus or minus on there. But remember that we're trying to find a radius here. A radius is not going to be negative, so it's just going to be the positive one. So this right here is the answer, except for we need to know what units go on there. So the answer for this one is the radius. Since this is a volume in feet cubed, the height is in feet. This is going to be feet right here. Okay, so the answer to number 12 is 3 feet. We plug those into the formula. We solve that equation. In this case, we had to undo the squaring by taking a square root. Okay, one of the problems is done for you on the assignment. Good luck with the rest of them.